Hello, everybody. I'm Andrew. I run developer relations at Fastly. I want to spend 20 minutes talking to you about rethinking our web applications for the decentralized era and what this new design style, design pattern of application might look like. Now, I've been making web applications since the late 90s, and basically every week someone writes a blog post that tells me that everything I know about building web applications is wrong and I should do it in a different way. And some of those ideas are really good and interesting and help us to evolve our understanding of how web apps should work and how distributed systems should work. And some of them aren't. And this is a very good example of a bad one, in that, if you are the UK government, then storing 1 million COVID test results in Excel is probably a bad way of designing a distributed system. So let's look at some better ideas for designing distributed systems. So let's start with a stack of components. This is a pretty traditional stack of components building up a software system. Now, pretty quickly we realized that the constraints of hardware are not very useful at the code layer, so we added virtualization. Now you have a container engine or a hypervisor, a bunch of operating systems, and all of this requires patching. And no one really wants to run their own data centers, so we pretty enthusiastically adopted infrastructure as a service pretty early on. But then around 2011, Heroku comes along and says, well, you don't really want to do any of that either, and why don't you do this platform as a service thing? And it turns out a lot of people didn't want to manage their own container management system or hypervisors or whatever. But accepting this higher level abstraction comes with some additional constraints, limitations that apply design decisions to your application architecture. And so Heroku actually kind of got ahead of this with the whole 12-factor app thing that they launched. And I really like this. I feel like a lot of these factors have really, they've kind of survived, and they're looking pretty good even today. So let's have a look at them now, because I think that a number of these actually are responsible and they stand out as empowering this move to platform as a service more than just being generally good software engineering principles. So the ones I would pick out are having stateless processes, running processes concurrently, which can be, which are resilient to being terminated randomly, and which treat connected services as equivalent to third-party integrations. So no kind of sneaky diving into the database through Unix sockets and that kind of thing. Then in 2014, Amazon came up with Lambda, and now suddenly we have functions as a service. So we now move up another layer of abstraction, and we don't have to worry about processes or runtimes anymore. And so now we're moving from platform as a service to functions as a service. We only manage our code, we only pay for infrastructure while we're actually processing traffic. This serverless world brought us a bunch of new constraints on things like per request processes, maximum runtime, and memory usage per request. And we had to learn new abstractions for stuff like state management. But we gained the benefit of seamless and almost limitless scalability. Interestingly, coming from a PHP background, I've always been quite familiar with the idea of per request processes. Kind of takes me back about 10 years in my career. So I feel like it's sort of everything that's old is new again, but isn't that always the case? So anyway, it seems pretty clear that the design factors that we learned to love from Heroku prepared us pretty well for migrating to serverless. With this new serverless philosophy, we've achieved huge advances in agility and scale. No idling costs, looser coupling, nothing to manage apart from code, easier and quicker to build and iterate on new stuff. But consider this, none of these benefits actually impact the user experience. They're all benefits for our development process. We still mostly run our application logic in central locations. And at most, we have a pretty dumb network of caches on a conventional CDN to replicate fully formed content in locations closer to our end users. Or maybe we create complex visible architectures to spread and balance loads across the world, but then we have to manage all of this stuff. And the more we try and create these proprietary solutions, the more brittle that architecture becomes. So let's revisit the stack of stuff we started with, most of which we've now abstracted away. That abstraction means that running code in more than one place is something that's no longer an impractical idea, but we're now really only held back by our ability to provision and manage those services in all of those different places. But let's think of this as more like a pipeline, a chain of processing nodes that goes from our core infrastructure to the client at the other end, each made up of a full stack of components, but crucially components that, apart from your core infrastructure, you don't have to manage, nor do you even have to provision them. Now we can decide where in the pipeline it makes sense to run our logic. As we move along the pipe, we find a larger number of parallel instances, and different benefits and constraints emerge. For example, the core infrastructure is probably the cheapest place to store large data sets, whilst the client is the cheapest place to do processing because it's free to you anyway. But on the client, of course, we only get access to one user's view of the system. At the edge, we might have access to state, but maybe it's not a complete view of the global state. Maybe it's a shard or a cache or a replica, or maybe it's a distributed data store designed to propagate updates asynchronously. With service workers on the client, we now have a second way to run logic there. And using WebAssembly, we can further extend and harness the capabilities of client devices. So this is becoming a really powerful platform at this end of the pipe. And then between the client device and edge networks like Fastly that have maybe a few hundred points of presence, we now also have the possibility of using things like 5G, introducing processing capabilities into ultra-local cell towers, which means your app running on tens of thousands of points of presence. But that shouldn't scare you. After all, you're used to running code on the client, and there are millions of those, or even billions for some of the apps that we all know and love, or love to hate. So, in summary, where we ideally put logic in this pipe is a function of things like the number of users that are affected or will benefit from the operation, whether we need access to state, what kind of state, whether that state is global or local, whether it needs to be up to date or complete, what kind of CPU or memory resources we need to complete the task, and any regulatory, privacy, or security considerations. For example, if you have data that can't leave the client device, then you have to do your processing there. In terms of benefits to the end user, the further we move down the pipe, the lower the latency for them. Here's a simple example of an app running on Fastly's edge that takes an input, converts the input, which we interpret as Markdown, into HTML, and then returns the rendered result using our computer edge platform. So from my home broadband connection here in West London, the average round trip time to complete one update cycle is under 10 milliseconds, which allows us to performantly execute a round trip on every keystroke. And importantly, this low latency can be expected pretty much regardless of where I am in the world, because edge networks are designed specifically to provide points of presence near major population centers. Now, a toy example like this is good for demonstrating the potential for offloading work to the edge. But let's consider my pipeline trade-offs and think about whether I'm running this Markdown app in the right place. So this is simple processing. It's using small self-contained logic. The input and output are both on the client side. There's nothing proprietary about the code. So this should probably be a process that we actually run on the client device. But let's imagine that instead of generating HTML from Markdown, which is provided on the client, my function is generating HTML from data that it loads from my CMS. So the CMS, or content management system, that sits in my core infrastructure and acts as my global data store. The edge, meanwhile, could hold a cache of API responses received from the CMS, and it could allow potentially many different combinations of pages to be built using the same set of core data that we've loaded from the CMS. For example, let's say two users both want to load the same page on a news website. Those two users might receive pages that both contain the same data from the same API call, but with differences based on those users' preferences, permissions, identity, A/B test groups, and so on, all of which we can compute and customize using edge attached data or state imported from the request itself and combined with API data loaded from the core infrastructure, which we've cached locally. Imagine as a similar situation to this, your React app doing server-side rendering for each user individually, completely obviating the need to hydrate apps on the client. Or maybe doing it selectively based on the computation capabilities of the client device. Move computation to the edge where you're dealing with low-powered devices. So none of this actually requires any major departure from the way we already think about web application architecture today. What I'm basically telling you is that stuff you would have done in your core infrastructure, but which you consider maybe to be a layer, one of the outer layers, like consider it to be an onion, just take the outer layers off, move them to the edge. Or maybe on looking at it from the other perspective, stuff that you would otherwise have done on the client, ship that to the edge if the client is underpowered. And there's loads of other things that we can consider if we look at it in this way as well, like low-hanging fruit. Things like anything that's to do with personalization, localization, authentication, or authorization, good low-hanging fruit to move to the edge. Also consider things like beacon termination or any kind of use case involving data collection. So a fun one here is, say, self-driving cars that are emitting large amounts of telemetry. All of that telemetry needs to be collected, filtered, most of it thrown away, and then the intelligence that is needed from that data can be extracted and then aggregated more centrally. But a more pedestrian example might be monitoring the performance of your website, or just beaconing user timing metrics or something like that. Facades are another really good indication that you can move logic to the edge. If you have any kind of middleware layer that is doing compatibility transforms for upgraded infrastructure or migrations between different versions of software, or you've got an API gateway, another great example. Anyway, all of this is pretty pedestrian. But to go further, we need to some extent to let go of some conventional ideas of what we want from our web applications and the sort of standard of perfection that we need and the standard of visibility that we need, and how we have these kind of ideas about how everything is essentially nested around a central core. We already have in some ways started to do this with the idea of having cached content out there on the CDN, which might be at some stage out of date. But I think it's worth properly kind of owning this and wrapping your head around the idea that as a design goal, perfection is actually a problem. Pat Helland, who used to work at Microsoft, wrote this blog post in 2007 in which he suggested that computing is memories, guesses, and apologies. And I thought that was an absolutely perfect illustration of what I was trying to say. You can't actually find this MSDN post on MSDN anymore, because I guess they've gone through like 3 different generations of MSDN since then, but you can find it in archive.org and it's well worth reading. It's only a few paragraphs long. So if we let go of, for example, the idea of a single global consistent view of the world, and we are prepared to deal with that, then what does that unlock? What does it allow us to do? Well, for example, we could start accepting rights much faster. Imagine that all the rights in your application are accepted at the edge and written to a local representation of the state, and then synchronized as needed with your core infrastructure or peer-to-peer with other edge servers in other locations around the world. And this is particularly interesting for use cases where the rights are updating data, which is typically needed to be up to date in the same geographic area where the rights are happening. So a good example of this would be dating apps like Tinder, or ride-sharing apps like Uber, where the data can be sharded in this way across the world, but still enjoy access to some view of the global state, even if it might be slightly out of date. So in an example of Tinder, you would swipe right on someone who's on the other side of the world from you, and there's a chance that if they swipe right on you at the same time, you won't match because your data, your representations of the global state are different. But with good enough data reconciliation, we could mop up these edge cases later and benefit from a super fast user experience, because 99% of the time people don't want to see people who are on the other side of the world. So let's say, using the same principle, we wanted to take, say, things like COVID track and trace data or test results or that kind of thing, accept them at the edge, receive a rapid response, keep the end device highly performant, and then re-emit that data to a centralized aggregator. And if we need to be sure that we've received all the data, the complete data set, well, have two aggregators. No Excel spreadsheets will be harmed in the production of the system. Now, with crushing inevitability, I'm obviously going to go all universe brain on you at this point and suggest that we get rid of the core infrastructure entirely. Are there any large-scale apps that can exist with no centrally coordinated state? Well, yeah, why not? And there are some pretty good reasons for doing that as well. Let's say, for example, apps whose primary purpose is to provide a means of storing and organizing your own personal private data. So things like Gmail, Pinterest, Dropbox, this kind of thing. These apps benefit from locating their primary data store for each individual user close to where that user is physically located. And with edge platforms, maybe we won't need to spin up separate storage instances dedicated to our own use in multiple cloud locations. Instead, just allow edge platforms to move the data to where it's used and kind of figure it out. A friend of mine who works for a newspaper that's a Fastly customer suggested to me that as the news cycle moves around the world, then we should manage where editorial content is stored so that it's fastest to read in locations where it's currently being read it's most in demand, like, you know, where it's currently business hours. And we would move the primary data store around the world during the day. Or you could think of regulation. Regulation is a big consideration we have to apply to decisions about the architecture of our applications, where a country or territory maybe has legislation that requires data to be stored in country. An edge network provides a way to make that a practical option for even very small websites. In this case, you can see, for example, someone in France might be directed to a edge location in Germany, even though there's a closer one in London, because they're not part of the same regulatory regime. And what about rate limiting? Rate limiting is a really interesting case because it tends to be something that you want to apply globally, but you don't want the latency that's associated with maintaining a global counter. Let's say you want to allow a user to make 1,000 requests an hour, but most good users will likely make all their requests to one edge location, but attackers will be annoying and send their requests evenly to all your edge locations. So, well, what if we start counting everyone locally, wherever they happen to be sending their requests? But then whenever one individual edge location reaches a low threshold, we'll then anchor that particular user's count to that location and broadcast a message to the rest of the network saying that if we see this user somewhere else on the network, then we should forward that request to the location that they originally met that threshold in. This means that most users will not encounter any additional latency, but for the users who are, you know, switching location a lot, they're going to still get a count that is consistent across the world. So this is a glimpse into one scenario in which it's a value for one edge location to talk to another directly. And you could also imagine this kind of thing happening in lots of other situations as well. Like, let's say, relaying chat messages between users who happen to be connected to different servers in different parts of the world. Or streaming game updates from users connected to the same multiplayer game session. So this is all pretty exciting stuff, and it gives us an idea of how future applications will benefit from edge computing. But how can we boil this down to some design principles that, kind of like Heroku's original design 12 design factors? Well, let's look at the ones that I inherited from the 12-factor app, and isolate the ones that I think are most relevant to us here. Stateless processes, concurrent processes, disposable processes, other services attached resources, and separated build and run stages. And I want to add to these a couple more and see what you think. Let's add remote state. An edge application assumes that persistent state is controlled remotely but cached locally. It updates local representations of remote state and makes use of mechanisms in the platform that reconcile updates to that state asynchronously. So I think in this kind of world, we shouldn't have to be inventing our own mechanisms for reconciling state. We should have mechanisms available to do that. And there should be lots of them to suit lots of different use cases. And the other one is no single view. An edge application doesn't need to have a complete and up-to-date understanding of the world in order to operate properly. Because if you start your architectural vision of your solution from the perspective that you need to know everything about the world at all times, then that's pretty limiting in terms of how you can actually distribute your app around the world. So if you start with the principle that you're never going to know everything in any one place at any one time, and you design that into the architecture of your app, then potentially you get to do a lot more interesting things with it. So I'm going to add those to the list and say, does anyone have any other suggestions for how we should think about changing the architecture of our apps for the edge compute world? And that is all I have. Thank you very much.
Super. That was the best description of why you'd want to move code to the edge I think I've ever seen.
Oh, thanks, Simon.
I have a question though.
Okay.
Which is,
shall I stop sharing?
What are some use cases that people are using edge compute for in the wild that are interesting and make use of this paradigm of moving that some state to the edge and shifting code to where it's best executed?
Well, I think the answer to that is not as impressive as I'd like it to be. I'd love to be able to say that there are lots of people doing all the things that I just talked about, and the reality is that there aren't really. And this is why I'm trying to, find people with interesting use cases and say, think about this stuff. I think it could be really exciting, and the tools are maybe not quite there yet. Fussy certainly can't do all of the things that I just talked about, but we will be able to, and I'm sure that Akamai and Cloudflare and CloudFront will as well. So this is the kind of thing we need to start thinking about as the next kind of big push in improving performance. I do know if people are using it for the telemetry stuff. So, collecting data, processing it at the edge, stripping stuff that you're currently not interested in, forwarding to aggregators, that kind of thing. So there's definitely a lot of that going on. I also know of people who are starting to build API gateways, purely at the edge. So for example, doing all your authentication, API keys, validating routes, checking inbound and outbound parameters, all that kind of stuff.
Interesting. Yeah, lots of thoughts going through my head. I think all of this comes back to some of the Q&A that we had in last month's London Web Perf, where we were asked, are CDN standardizing on edge compute languages? And I think I've extended that to, are we as an industry standardizing on what edge compute is for, rather than just doing it because everyone else is doing it? What are the kind of fundamental constructs around moving logic to a more diverse distribution of locations?
It's a very interesting point, and actually it's a little bit of a conflict in a way between those of us, and I definitely am in this camp, who feel like this is a platform and is a programming platform, and I want to provide customers with the ability to create stuff, whatever their heart desires really. And I don't feel like I'm in a position to predict what that's going to be. But by the same token, the CDN industry has always been a kind of switches and buttons kind of world, right? Where you sign up for an account and you log into a control panel and you create rules, and the web UI is good or it's bad or whatever, but ultimately you're not programming. And I think that is the fundamental shift we have to go through, is to recognize that we're not building individual products, but we are providing a programming platform. And once you get to that point, you think, well, it's really a case of like discovering as many use cases as possible rather than trying to target products to one or two.
Yeah, you always narrow yourself down. It's easy to narrow yourself down to another feature, but edge compute gives us the ability to be broad. One of the use cases I worked on with a client last week was a holiday company who wanted to personalize the homepage based on which was the closest airport to the visitor. Really simple thing, and they can do it at origin, but why not do it at the edge? Because it's a really simple transform.
Perfect things to do at the edge. I mean, you can take this to extremes. I was talking to someone the other day, and I suggested that airline seat availability data is something that is of primary interest to people in the origin city of the flight. So if I'm flying from, say, San Francisco to London, do you remember doing that once upon a time when we flew around the world?
Long distant memory.
If I'm flying from San Francisco to London, then I am probably in San Francisco. Therefore, that's where I'm going to want that data to be stored. I think going to that kind of level of detail sounds ridiculous, but ultimately, if you don't have to do anything to make that happen, you just say, here is a pile of data, and here are some operations that are happening on that data, figure it out. And then a platform could be like, okay, well, this data seems popular over here, so we'll move it over here. And that kind of thing I think is perfectly realistic in 5 years' time.
Excellent. Hopefully sooner. We have a question from Pierre, which is prefaced as a naive question, but probably not. Can a user be pinned to a CDN POP in an edge network, and what would be the advantages and disadvantages of that?
Can a user be pinned to a POP in an edge network? Yeah, so this is a practice that is often called sticky sessions, where naively for example, someone requesting your kind of canonical domain might be redirected to www6.example.com. I think some of us can remember that kind of happening like 15 years ago. Doesn't really happen that much anymore, and there aren't that many benefits to doing it. We also find that the mapping of users to POPs is relatively stable, and there's an enormous number of fancy DNS tricks that you can do these days to make that more likely. So, especially with IPv6, where you can virtually own individual routes for individual users or individual user ISP combinations. So I would say, yes, users can be pinned to POPs. Is there an advantage to doing it? Maybe sometimes. I would say probably rarely. Simon, would you disagree violently with that?
Can I ask you a follow-up question first?
Yeah.
Okay.
In your diagram where you had origin, edge, 5G
okay.
client, a browser client, what happens in that 5G tower space where somebody's walking and essentially they may be moving along? No, it's does it happen at the edge, or are you gonna at the tower level, or are you gonna pin them further back? Probably at the
so that
CDN POP.
You would pin them to the POP, not to the there would never be a reason to. I mean, that's a strong statement, but I would say that I can't think of any use cases where it would make sense to try and pin someone to a specific tower. I mean, at some point you're going to walk out of range and then you're stuffed. But also like the question I thought you were going to ask me, which is the one that I always think is funny when people ask me, is like, didn't the whole 5G edge processing thing die? And I think the answer to that is, I don't really know. I don't know anyone who's doing it. I do know of demos that exist that work. But yeah, I would love to know if anyone's actually adopting 5G compute and using it for anything in the wild. Yeah. Do you know of any, Andy?
It applies best to IoT, doesn't it? When you want to have local processing.
That is very much the sell, is that you could have, say, an ML model on a 5G tower, and you could do your processing without having to tax the device. I'm not entirely sold, but I mean the point I was trying to make was that there are potentially different levels. I mean, even within the edge layer, there are different levels. At Fastly, we have a thing we call shielding, where you go through 2 layers of Fastly before you get to your origin. I think Cloudflare call it tiered caching, and probably I might have a thing for it as well. Yeah. So I was trying to kind of make a kind of bigger point, but I think even within the edge, you've got layers that go all the way from the origin to the client.
Yeah. And my only other comment on pinning to an edge node is, if you have state that would require it to be instantly available at different CDN POPs, then it's probably not the best use of edge compute. If you need someone to be pinned to that edge server for the logic to work, because you can't guarantee instantaneous replication.
No, exactly. I mean, you've always got to battle with that. You can either have, what is it? I always get this wrong. You can either have partition tolerance or availability or consistency.
Yeah, cap.
Yeah, it's the one.
Cool. We've got 2 more questions. We'll get through them relatively rapidly to finish up at 20 past the hour. Zlatan asks, I can see how moving logic to the edge contributes to network savings and performance. Would that not expect the end user devices to be similar in features and performance? E.g., have the ability to process locally at a certain rate. Would that not provide a sort of double standard of performance? It's a question that needs a bit of unwrapping.
Yeah, help me unwrap.
So, would that expect the user devices to be similar in features and performance? I think it's the opposite. I think moving logic to the edge means that your devices don't have to do as much, and it becomes a little bit more tolerant of device diversity. If you're moving client-side logic to the edge, it doesn't have the same effect if you're moving origin logic to the edge.
I can sort of see the opposite perspective, though, that you could argue that I'm suggesting that we're essentially pushing logic down the pipe. So I'm essentially making an argument for ever more complex logic out in the field rather than at the core, and that's true. But the main point is that it's not necessarily client logic. It could be being executed at the edge. And indeed, it could be an either-or situation. Like there could be a module of logic that can execute on the client or at the edge, depending on the capabilities of the device. So to some extent, it is actually a more inclusive strategy, because for those devices that can do it, we do it on the device because it's slightly lower latency for the user, and it saves us money because it's the user's compute rather than our own. And for devices that can't do it, we'll do it at the edge.
Yeah, it goes back to Giacomo's comment about data saver. We should observe those client hints as to whether it can process things at the edge or on the client. Sorry.
Yes.
One
of these days, one of us should do a blog post about how many requests we see that have data saver enabled and whether it makes any difference to the number of bytes in the response.
Yes, I think we have one on the Akamai blog. I'll dig it out for you.
Oh, okay.
The answer is not many.
Of course you do.
Not many devices and not much difference. But it's a two-way street, isn't it? Okay, the one last question, which is an extremely loaded question from Matt Hobbs, which I'll summarize as
always,
eggs and baskets. If a company places all of their eggs in one CDN basket and builds an edge compute application, does that mean that the CDN could then abuse that, increase their pricing, and make it a profit machine? And do you see this as an issue that may put people off using edge compute, that vendor lock-in?
No.
Go.
I think I think this is a slightly unfair question, because I would like to challenge anyone who has a large deployment on GCP to lift and shift that deployment to AWS and tell me how easy that was. And I'm pretty sure that taking an edge compute application, given the current state of edge compute and the sophistication of the platforms, which is like nowhere near as complex or as sophisticated as a central cloud provider, you are going to face far less barriers and far less engineering effort to move to another provider. As they get more complex, yes, definitely, this is going to be more of a problem. But maybe we'll see standards. I don't know. You know, Terraform is getting there. Is Google talking to me? Hey, Google.
About standardization. And I not just moving from GCP to AWS, but moving a CTN config itself is, for a complex config, is a week's worth of work at least for a dedicated engineer.
Sure.
Edge logic is dealing with requests and responses. It should be quite atomic. It should be easy to transition. So
yeah,
no more than there already is vendor lock-in.
Yeah. Okay. Fair enough. That's a slightly different angle on it, but also true. Yes. So essentially, you're saying it's already complex and difficult to move. So why should it be any more complex and difficult to move? Yeah, I think the fastest approach is to use is to let you upload WebAssembly binaries, and so that is to some extent portable. But of course, you're going to be using host calls, which will only work in one provider's environment or another. So ultimately, it's hard to see a solution that would be entirely portable.